Imagine like thousands of tons of liquid metal just flowing at over 1,000 degrees.
Right, yeah.
Now imagine the power grid suddenly failing. All of that metal just instantly freezes into, well, solid rock, right inside miles of incredibly delicate industrial piping.
It's an absolute nightmare scenario.
Yeah, and on March 28th, that wasn't just some hypothetical disaster. It became a catastrophic reality for, one of the most vital supply chains on Earth.
Oh, absolutely.
Usually when we hear a term like force majeure in some corporate press release, it sounds really abstract. Like it just translates to superior force or an act of God.
Yeah, it's just the paperwork you file, right? When a shipment is delayed and you need that legal shield to protect your company.
Exactly, to avoid breach of contract. But today, we're diving into what happens when force majeure instantly freezes 9% of the world's supply of a totally critical raw material.
And, the fallout from that kind of freeze, it moves so much faster than people realize. It really exposes the fact that our modern industrial world operates with basically zero margin for error. Yeah. We build these massive, complex dependencies, just kind of assuming the baseline materials will always, be there.
Right, that they'll just keep flowing. So for today's deep dive, we are pulling from a really detailed intelligence post from the Patreon community, KULE. And they've done this incredible work synthesizing internal company documents, which were originally brought to light by Bloomberg, alongside deep research from CITIC Securities, market analysis from Kepler, and reporting from the Washington Examiner.
It's a really comprehensive set of sources.
It is. And our mission here is to unpack how a single series of events on March 28 basically crippled the Middle East's largest aluminum producers and sent this massive shockwave through global manufacturing.
Yeah, a systemic shockwave, really. And to understand it, we have to look closely at the incredibly fragile physical processes that happen, long before a piece of metal ever reaches a factory floor.
Right. But before we get any further, I do want to be crystal clear with you, the listener. We are analyzing an event that's rooted in a highly sensitive, deeply complex geopolitical conflict.
For sure.
The source material details Iranian missile and drone strikes on Middle Eastern infrastructure. And in this deep dive, we are strictly and impartially examining the geopolitical and market facts presented in these reports. We aren't taking any political sides.
No, not at all.
We're not endorsing any viewpoints. We're literally just here to impartially report on the data, unpack the supply chain mechanics, and understand the economic ripple effects that are laid out in the original source material.
And what's fascinating here is how invisible this kind of heavy infrastructure is to us in our daily lives. I mean, we rarely think about the vulnerability of the raw materials that make up the cars we drive or the planes we fly in.
Yeah, not until the exact moment that supply stops.
Exactly.
So let's start right at the point of failure. On March 28, coordinated Iranian missile and drone attacks targeted Emirates Global Aluminium, or EGA, they're the Middle East's largest aluminum producer.
Massive operation.
Huge. And specifically, the strikes hit their flagship Al Tawila smelter near Abu Dhabi. Following the strike, EGA declared force majeure on a portion of its order backlog and just suspended deliveries.
Right.
But I want to dig into the physical reality of that facility because the attacks knocked out power to the complex. And why is a power outage such an apocalyptic event for an aluminum smelter?
Well, the mechanism of aluminum smelting is entirely dependent on continuous, just massive amounts of electricity. The industry actually refers to aluminum as solid electricity.
Wait, really? Solid electricity?
Yeah, that's the nickname. Because inside a smelter, you have these massive swimming pool-sized vats called electrolytic cells, and you dissolve this powdery substance called alumina into a bath of molten salt.
Molten salt?
Yeah, specifically cryolite. And to keep that salt molten and to separate out the pure aluminum, you have to maintain temperatures around like 1,000 degrees Celsius.
Wow.
And you do that by pumping hundreds of thousands of amperes of continuous direct electrical current through the cells.
Okay, let's unpack this. Because I'm imagining a massive continuous plumbing system. But instead of water, it's pumping liquid metal and molten salt.
Right.
So if the power suddenly cuts out, the temperature inevitably plummets. It's like, I don't know, like hot wax instantly hardening inside a complex network of tiny pipes.
That's a really good analogy, actually.
Yeah, like it doesn't just stop flowing. The sudden freeze literally destroys the system from the inside out.
Oh, the destruction is incredibly thorough, because when thousands of tons of molten metal and salt freeze solid inside that precise internal architecture, the physical expansion and contraction just crack the carbon linings of the cells.
So it's not like you can just hit a switch and reboot it.
No, no, you cannot simply turn the power back on and melt the block. The conductive pathways are totally ruined, so you actually have to physically jackhammer the solidified rock out of the vats.
Are you kidding?
I'm serious. You have to rebuild the delicate carbon cathodes from scratch and entirely reconstruct the cell line.
Okay, that perfectly explains the rhetoric coming from EGA's leadership then. Their chief executive, Abdul Nasser bin Kalban, stated the company was deeply dismayed and cited significant damage.
Oh, yeah.
When you realize they have to essentially dynamite solid metal out of their machinery, the timeline makes terrifying sense. Because the Al Tawila facility produced 1.6 million tons of molten metal in 2025. And EGA warned that fully restoring the site after this kind of deep internal system freeze could take up to 12 months.
Yeah, a full year just to return to baseline production. It really illustrates the severity of an uncontrolled shutdown. It transforms a localized kinetic strike into a long-term infrastructural paralysis.
But the thing is, that paralysis didn't stay localized. EGA wasn't the only casualty on March 28. The supply chain shock expanded geographically almost instantly.
Right, because of Bahrain.
Exactly. On the very same day, Aluminium Bahrain, which is known as ALBA, suffered attacks on its plant too. And this is another massive 1.6 million ton per year facility.
Wow.
They actually reported 2 employee injuries during the strikes.
Yeah.
So 2 absolute giants of the region were hit simultaneously.
And you also have to factor in the vulnerabilities of the broader regional energy grid, which caused major disruptions before a single facility was physically struck. Like
Yeah.
Qatar's Catalum had already slashed its production by about 40%.
Which is wild because the source material notes that Catalum's 40% cut wasn't due to direct missile strikes on their smelters. It was because of natural gas shortages caused by the broader conflict.
Right.
But how does a natural gas shortage directly force an aluminum smelter to shut down nearly half its operations?
Well, it comes back to that solid electricity concept we were just talking about. A large aluminum smelter consumes as much power as a major city. And in the Gulf, that immense power is generated almost entirely by burning natural gas in these massive turbine power plants.
Yeah.
So the smelters, the gas processing facilities, the pipelines, they're all part of one tightly interconnected energy ecosystem.
Oh, I see.
Yeah. If a broader geopolitical conflict damages regional gas infrastructure or, forces a diversion of gas just to keep municipal lights on, the grid operators have to throttle power to the heaviest industrial users.
To prevent the freezing scenario.
Exactly. The smelters are forced into controlled partial shutdowns to prevent that catastrophic sudden freezing scenario we just discussed at EGA.
Okay, so combining the direct shutdowns at EGA, the strikes at Alba, and the energy force cuts at Catalum, these disruptions took a massive chunk of the Gulf Cooperation Council's primary aluminum production offline.
Yeah, a huge chunk.
The reports estimate this represents about 9% of total global output. Now, I think my instinct, and probably the listeners too, is to assume governments have strategic stockpiles for exactly this scenario, right? Like we do with oil.
You'd think so, yeah.
Why isn't some national reserve swooping in to plug this gap? Is 9% really enough to cause a global panic?
If we connect this to the bigger picture, the illusion of a safety net completely disappears. Because unlike crude oil, there is no massive centralized strategic reserve of industrial aluminum just sitting in government warehouses ready to deploy.
Really, none.
No. The global commodities market operates on a ruthlessly optimized just-in-time delivery model. Every single ton of that 9% was already contracted, scheduled, and factored in to the daily manufacturing lines of downstream companies around the world.
It's basically completely spoken for before it even cools.
Precisely. And the demand for aluminum is highly inelastic in the short term. I mean, if an automaker's assembly line is tooled to weld aluminum chassis this quarter, they cannot just pivot to using steel or carbon fiber on a Tuesday.
Right, they need the exact materials they planned for.
They absolutely must acquire the specific metal they designed the vehicle around. So when 9% of the global supply vanishes overnight, the remaining 91% cannot easily absorb the shock because every other smelter on Earth is already operating at maximum capacity.
Wow.
You immediately create this catastrophic gap that triggers a desperate scramble for physical material.
And that desperate scramble is incredibly visible when you look at the immediate financial fallout. The physical freeze of that metal in the Gulf sent an explosive price shock straight to trading floors in London and Japan.
Oh yeah, the numbers are wild.
Aluminum futures on the London Metal Exchange, the LME, spiked 6% on the very first trading day after the attacks, And by April 10th, the reports show that prices were up roughly 46% year on year.
A 46% increase in a foundational raw material is just devastating to the profit margins of any downstream manufacturer. It completely rewrites the basic economics of building a car or a plane or even a skyscraper.
And the projections going forward look even more severe, right?
Yeah, they do.
Commodity analysis firm Kepler estimates that production losses stemming solely from the damage to Alba and EGA could range from 1.13 to 1.79 million tons in 2026. Kepler also warned that further escalation in the region could push benchmark prices toward an astonishing $4,000 per ton.
And crossing that $4,000 threshold exerts immense financial pressure. But, the benchmark price only tells half the story. The benchmark is just the global average, essentially a paper contract. The true cost of the crisis is actually found in the premiums.
Yes. Here's where it gets really interesting to me. The report highlights a Japanese aluminum producer that raised its bid premium to $350 above the LME price.
Yeah, which is unheard of lately.
It's the highest premium seen in over a decade. But I have to admit, I have some confusion here regarding the mechanics of this market. If the LME benchmark price is already skyrocketing up 46%, why is a buyer in Japan voluntarily offering to pay an additional $350 markup per ton on top of that inflated price?
Well, the distinction between the paper market and the physical market is super crucial here. The LME price sets the baseline value of the metal in the abstract. But an abstract contract in London does not feed an automotive stamping press in Tokyo.
Oh, wait, obviously.
So the premium is the surcharge a buyer pays to guarantee the actual physical delivery of the metal to their specific geographic location. It covers localized logistics, securing shipping vessels, maritime insurance, all of that.
So they're basically paying for the physical reality of moving heavy metal across the ocean. But why is Japan's premium so incredibly high compared to the rest of the world?
Geography dictates their vulnerability. Japan is an island nation with high domestic energy costs, meaning they have virtually no domestic aluminum smelting capacity.
Oh, so they have to import almost all of it.
Exactly. They rely almost entirely on seaborne imports of primary aluminum. And a massive portion of those imports historically comes from the Middle East, traveling on cargo ships that must navigate out of the Persian Gulf through the Strait of Hormuz.
Which, the source material notes, was already a massive logistical choke point. The simultaneous closure of the Strait of Hormuz was disrupting global shipments even before the smelters were directly targeted by missiles.
Right, so the Japanese buyer isn't just paying for standard shipping. A $350 premium is a quantifiable measure of desperation.
Wow.
They're paying a massive surcharge to secure whatever scarce metal is available and to incentivize shipping companies to navigate severe geopolitical risks, skyrocketing insurance premiums, and disrupted maritime routes just to keep their domestic assembly lines from halting completely.
That desperate need for metal really explains the panic we are seeing from industrial buyers globally. And honestly, it exposes a terrifying math problem for manufacturers in the United States who might think they're insulated from Middle Eastern geopolitics.
Oh, they are definitely not insulated.
Not at all. The aerospace and automotive sectors are under immense pressure right now, and the reports explain exactly why. Gulf smelters have historically been the key suppliers of high-purity aluminum alloys.
And high purity is the critical factor there. I mean, you can use standard-grade aluminum to manufacture a beverage can or a window frame.
Sure.
But the structural crash frame of a modern electric vehicle or the fuselage of a commercial airliner, that requires highly specific, advanced alloy blends with absolute structural integrity.
Right.
And only a select few advanced smelters globally can produce these high-purity alloys at the scale aerospace and automotive giants require.
Which brings us to a really stark domestic reality highlighted by the Washington Examiner. In 2025, the United States produced a total of only 660,000 tons of primary aluminum domestically.
That's practically nothing in the grand scheme.
Right. To put that number into perspective, the entire national output of the United States is less than half of what Alba's single facility in Bahrain produces in a year.
It's wild to think about.
So what does this all mean for the listener? Like, how is a U.S. manufacturer supposed to maintain steady production of airplanes or cars when their entire domestic supply chain wouldn't even cover half the output of one disabled facility in the Gulf?
This raises an important question about the fundamental structure of the modern economy, because over the last few decades, global manufacturing made a collective, calculated choice. Smelting aluminum requires massive amounts of energy, as we established.
Yeah.
So we offshored our most energy-intensive industries to regions like the Gulf because they offered abundant, cheap natural gas. It made perfect financial sense on a spreadsheet to just trade supply chain resilience for cheap energy.
The KULT report actually cites Ciatic Securities on this, who identified electrolytic aluminum as a key commodity to watch precisely because of this dynamic. The March 28 strikes fully exposed the strategic vulnerability of concentrating power-hungry metal production in a single geopolitically volatile region.
We built a system dependent on multiple overlapping single-point failures.
Yeah.
You have a geographical choke point in the Strait of Hormuz, you have a regional energy choke point with natural gas processing, and you have the infrastructural choke point of the smelters themselves. When one of those points fails, it strains the whole system.
And when they all cascade simultaneously.
You trigger a historic supply shock that halts assembly lines halfway across the world.
So just to quickly recap our journey through these reports today. We started with a physical, coordinated attack on Middle Eastern facilities that knocked out the power grid, causing an uncontrolled shutdown that instantly froze the intricate internal architecture of these massive smelting operations.
Right.
That physical freeze evaporated 9% of the global supply in the blink of an eye. The sudden scarcity sent London market prices skyrocketing 46% year-on-year, forced nations like Japan into desperate high-premium bidding wars just to secure physical shipments through closed straits, and is currently threatening the production capabilities of the global aerospace and automotive industries.
And the entire crisis traces back to that one initial failure of the power grid and the unforgiving physics of an electrolytic cell rapidly losing heat.
So the next time you board a commercial flight, maybe take a moment to look out the window at the wing. You aren't just looking at a static piece of metal. You're looking at a tightly optimized miracle of global logistics. You are looking at solid electricity sourced from complex regional power grids, shipped through narrow geopolitical choke points, and delivered just in time. And right now, the global machinery required to forge that metal is powered down.
Which leaves us with a really necessary paradigm shift to consider, because if primary aluminum smelting is this fundamentally fragile and relocating those massive energy requirements is just economically unfeasible, will this crisis force global manufacturing to aggressively pivot toward aluminum recycling?
Oh, that's an interesting point.
Yeah, because melting down scrap aluminum requires 95% less energy than refining primary metal from raw ore. If the Gulf supply chain remains compromised, we might be watching the exact moment where domestic scrap metal ceases to be just garbage and becomes the most fiercely protected strategic resource in the manufacturing world.
It's a fascinating pivot. When an entire global system is built on perfectly timed, uninterrupted flows of incredibly hot liquid metal, a declaration of force majeure is far more than legal paperwork. It's the sound of hot wax hardening in the pipes, freezing the system from the inside out. Thank you for joining us for this deep dive. Keep questioning the world around you.